Okay, so welcome back for chapter 2. This chapter is really quick. It focuses on decimals. And so we'll be talking about comparing decimals, rounding decimals, adding, subtracting, multiplying, and dividing decimals. Okay, so let's go ahead and get started with section 1. It's comparing decimals. In this section, I'm not really going to have you do any for homework just because this is fairly simple, so I think this lesson should help. Okay, of course, I'm still going to provide this for you. Just in case you do want more practice, you have all of these here to compare or add, subtract, multiply, or divide. Okay, so let's go ahead and begin with comparing decimals. Okay, this is section 1. And so we need to understand place values. Okay, so I put an example here. I chose 2.840. The 2, of course, anything that's on the left side of the decimal would be our whole numbers. So I put their whole. And so anything on the right side of our decimals, those are our smaller units. Those are less than a whole number. Right? Those are the little numbers that you find in between a number line. And so we begin with the very first one. The first place value to the right of the decimal is our tenths. So that would be the eighth in this case. Our 4 will be hundredths. And then our 0 there would be thousands. If I kept adding, well, then we still go 10,000s, 100,000s, please, etc. Okay. Now, what else? So we put the further down we move from the decimal, the smaller the value. Okay, so what I mean by that is to the right side. So, of course, the tenth is bigger than the fourth, the hundredth. And then, of course, the tenth is bigger than the thousands, the hundreds is bigger than the thousands. And if we were to have more numbers here, well, that thousand would be bigger than the actual, whatever numbers are next. So the example that I put here, of course, is that our penny is less than a dime, right? The value we have a penny is worth 1 cent. And you see that it's in the hundredths place. So a penny is worth 1/100th of a dollar. And then, of course, we have our dime, which is 1/10th of a dollar. Okay, and so, of course, our dime would be bigger. Symbols that we need to use here, and these I did get in the practice exam, so that's why I decided to cover it. We need the greater than, less than, and the equal to. Okay, so these could be flipped, and you can still read it as greater than, less than, or equal to, which I'll get into what I mean by that in a little bit. And it would be a equivalent statement or inequality to do that. Okay, and so this is what you'll be seeing in the exam. Of course, there's other signs like the greater than or equal to or less than or equal to, but we don't need those right now. So that's why I decided to include them. So let's start comparing some of our decimals, excuse me. Okay, so I put 44th hundredths is blank to 45th hundredths. And so, of course, comparing, we need to look at the place values. That's why I say we need to understand place values. I look at my whole numbers. Do I have a whole number? No, it's 0. That's also 0, so those are equal. So I can't really decide a tiebreaker there. So then I move to my next unit. In this case, it's on the right side of my decimal. Let me cover these up because they might be... Right, and so... no, this is also equal. We have a 4 and a 4 in the 10th place. So I can't decide a tiebreaker there. So then I move to my 100th place. Which one is bigger? Is the 44 or the 4 or the 5 is bigger? In this case, the 5 is bigger. So 45 hundredths is bigger than 44 hundredths. So when I put this here, the symbol I should be using is 44 hundredths is less than 45 hundredths. Then if you notice here, I put or. And you'll see it like this, okay? Because when I did a problem on the exam, they gave me an equation that looked like this, but then the answers look like that. I don't know if that makes sense. Like the problem was set up this way, but when you could go to your answer choices, they're set up this way. So you need to be able to use the symbols, I guess we'll call it invertedly. So it's in one way or the other. So in this case, 45 hundredths is greater than 4400s. And these two, although they're, the little symbol might look flipped, but if you notice the big mouth, remember we used to call it the alligator mouth at school, like it was opening, it always eats the bigger because it has more meat to it. Okay, in this case, it's going to eat the bigger number, right? And so this is how we do these. Okay, we compare the place values. Let's do another one. So I have 9.650 is blank to 9.65. So again, we'll look at the whole numbers. I have a 9 and a 9, so I can't decide there. So then I look at the number next to it, or neighbor, and I say, okay, so this is a 6, and that's a 6. I still can't do anything there for the tenths, so let me look at the hundredths, please. I have a 5 and a 5. So I can't do anything there. Let me look at the thousands, please. I have a 0, and I have nothing here. So that means that this one is smaller than that one, so there's nothing there. Or is this one bigger than that one because this one actually has a 0? Well, let me tell you that these are actually equal to each other. This is the same, they have the same value, because I could put a invisible 0 there. Okay, this one they decided to include it, but I could definitely just say I don't want it there. And these two have the same values. Is it okay for me to do that to that 0? No, because that 0 is not the last digit on the number. When it's the last digit, you can omit it and it won't lose value. But if a 0 is in between numbers or it's the first number, you cannot omit it, only when it's at the very end. So these two are actually equivalent values. One decided to include the 0, which didn't change at all. Didn't change the value of this 9.65. In this case, they decided not to include the 0. Okay, but it's exactly the same thing. I could put it there, and it doesn't change the value, so I don't have to include it. So here, of course, it's the same thing, like I said. So these two are also equal. 9.65 is equal to 9.65, and then of course they include that 0, but we don't have to include it. I'll scratch it off. Okay, hopefully that made sense. Next one. We have 0.881 is blank to 0.871. Okay, so we'll begin at the whole numbers. They're equal. Let me look at my tenths. They're equal. Let me look at my hundredths. Oh, there's a difference there. Which one is bigger, the 8 or the 7? Of course, the 7. So I don't need to move further to the thousands. I can ignore that 1 because my 8 was bigger than my 7. I know that 0.881 is greater than 0.871. In this case, it's backwards now. So I just need to make sure that the little alligator mouth is facing my bigger number. Okay, and I know I can say this. 871 thousandths, that's the correct way to say it. 871 thousandths, we still look at the place value for that one, is less than 881 thousandths. Okay, if I'm reading it this way, it's 881 thousandths is greater than 871 thousandths. I believe this is our last one here for this section. Okay, so I have 5.82 is blank to 5.69. Again, whole numbers equal. Let me look at the next one. Oh, I don't have the same number, so I can have a tiebreaker here. I know my 8 is bigger than a 6, so the alligator is going to want to eat the bigger number. So 5.82 is greater than 5.69, or 5.69 is less than 5.82. Okay, and so with these comparisons, this concludes the first portion, which is comparing decimals. If you have any questions, please let me know. Okay, hopefully this helped.